Welcome to Math Coachism. This presentation is a deep dive into fractions, understanding how students conceptualize and develop generalizations. In Teaching Student-Centered Mathematics explains 4 reasons why students struggle with fractions. The authors start by asking the readers to think back to when we learned about numbers, how we started with counting, then counting on, mental strategies, using concrete objects, story situations, and finally progressing to algorithms. However, as students learn about fractions, far few concrete objects and visuals are used instructionally. Typically, teachers tend to focus more on the algorithm, and story situations comes at the end of the learning experience. As a teacher or student, how many of you have had similar experiences? When teachers and or students focus more on the algorithm and not be provided adequate time to a learning progression model such as concrete, representational, and abstract, students tend to overly rely on their whole number understanding, which is a misconception students might develop. So it is imperative for teachers to be aware of these 4 misconceptions so they can anticipate and plan accordingly. Using visual models in mathematics is an integral part of students developing their conceptual understanding. However, exposing students to a limited few does not support students' ability to form generalizations. According to Principles to Action, Ensuring Mathematical Success for All by the NCTM, effective teaching of mathematics builds fluency with procedures on a foundation of conceptual understanding so that students over time become skillful in using procedures, flexibility as they solve contextual and mathematical problems. Models are mental maps mathematicians use as they solve problems or explore relationships. Students do not start here, but mental maps are developed over time. How many of us might see a math problem and visualize a number line or another mathematical model? There are 3 models used to conceptualize fractions, which are area, also known as region, set, and length. But in this presentation, we focus on number lines. We will discuss all 3 types of models as we progress through this presentation. Here are 3 models that are considered area models. The circle model is the most commonly used area model. The circle shows the part-whole concept of fractions and the meaning of relative size of the part to the whole. However, circles can become difficult to partition into the same size sections. Using a rectangle, a geoboard, pattern blocks, color tiles, or grid paper have been proven to be more flexible and allow teachers to see if students partition correctly. The idea of referring to a collection of counters as a single whole makes set models difficult for some students. However, the set model helps establish important connections with many real world uses of fractions with ratio concepts. As you can see, I selected to make two sets that wasn't obvious where you can find the one third. In the first set, we notice that we have different colors. And as we can see in the presentation, it is written that size, color, or shape of the objects doesn't determine or define the set. The total collection of the set is 6. So we have to find one third of 6. And as you can see, one third of 6 is 2. And in the second set, we were given two circles. So the set is defined by 2. So we need to find what is one third of 2. So the first step, a student might consider partitioning the circles into thirds. And once they partition each circle into thirds, shading or coloring one third of each of the circles. And as you see, we have two one thirds shaded. So one third of 2 is 2/3. We will talk more about this later on in the series. A number line is one of the models that can be used for length models. Other length models include Cuisenaire rods, paper strips, and fraction strips. The Institute of Educational Science report on the effect of teaching of fractions argues that number lines should be the central representation tool. The number line is a significantly more sophisticated measurement model than Cuisenaire rods because it helps students to understand a fraction as a number rather than as one number over another number. When number lines aren't already partitioned, students can use the benchmarks 0, 1/2, and 1 to make estimates or use a measuring tool to be more precise. Each part of the series is based on these four misconceptions. Make sure that you are connected to Math Coachism on all social media platforms to make sure you stay updated. Thank you for participating in today's presentation. Please be sure to like, subscribe, or follow me on social media so you can stay connected. Have a great day.